Hello there, friends and neighbors. I want to talk about how to compute Poisson probabilities. So you use the Poisson process when I've got a discrete event, a thing happening, that occurs over a continuous region, such as time or space. And so, for example, this is important in auto mechanics because you want to know how often a certain type of car is going to break down, or a certain feature or function within the system will break down. It's important in business because you'll want to know the probability that your business fails within the first 5 years. It's very common that a new business fails within a first continuous interval of space. So you need to allocate enough funding to stay afloat until then. Okay, and all of this depends on Poisson probabilities. So an event that follows this distribution is called a Poisson variable. So we've got here, in analyzing hits by bombs in a past war, a city was subdivided into 703 regions, each with 0.5 squared kilometers. A total of 541 bombs hit the combined area of the 703 regions. The Poisson distribution applies because we're dealing with occurrences of an event, a discrete event, bomb hits, yes or no, over some interval in this area. In this case, it's the area, 0.5 kilometer regions. What is the mean number of hits per region? Well, a simple thing to keep in mind about the Poisson, part of what makes it relatively easy to do, is that it has mean equal to the variance, which is equal to this number called lambda. Let me go just a sec here. Okay. So what we have here is 703 regions, each are 0.3 square kilometers, and we have 541 bombs. If we wanted to compute the mean number of bombs per square kilometer, we would compute that by taking 541 divided by the square kilometers. That's not what this question asks for, however. Find the mean number of hits per region. So that would be done more simply. Bombs divided by regions. So I've got 541 over 703 equals 0.7696. So I'm going to copy that and paste that as my answer, and we can see that that is the correct answer. Okay. I've got a hint that I wrote here that explains about the parameter lambda. The Poisson is a very simple probability distribution in that this parameter, which we'll call lambda, is the mean and the standard deviation, mean and the variance, and it's just this number called lambda. It's the number of successes divided by the continuous space. So mu equals sigma squared equals lambda. Now, that's it. When I want to get the variance, sigma, that's the square root of sigma squared. Sigma equals the square root of sigma squared, square root of lambda. So that equals square root of this. That's the standard deviation of the Poisson distribution. Find standard deviation there. And the hint says the same thing. Oops. I mean, in the variance of the same value, you need to fix that. The region is randomly selected. Find the probability that it was hit exactly twice. So in Excel, the formula we use for that is Poisson. So I'm going to go do that. The formula will be equal Poisson, and I put an x, the number of successes, and lambda, I'll just write mu, the mean, and then I want 1 for cumulative, or 0 for not. Okay, so this equals Poisson. X is 2 successes. Here's the mean. And I do not want it to be cumulative. I want exactly 2, not 2 or fewer. So hit enter, And there it is. That's the probability. 0.137. Done. Based on the probability above, how many of the 703 regions are expected to be hit exactly twice? An expectation means I compute the probability times the number. So 703 times 0.137 is how many I expect. So 96.4. Okay. Copy that, paste it in. And lastly, if a region is randomly selected, find the probability that it was hit at most twice. It means it's hit 2 or 1 or 0. That means it's 2 or less. It means it's a cumulative probability, which means I just set that equal to, I'll set the last argument equal to 1. I do want it cumulative. Okay, and x is 2, and mu is right here in cell B50. And give it a quote. That's it. 0.9568, etc. Now I can submit this, and it will tell me I am right. Hooray! Poisson.